Okay, so this is the last of our 3 videos on the abstract class GameObject. We've got a GameObject class here that's abstract. I've got a game runner that has my main method, and I've got these 3 classes that extend GameObject. So if I look in Tower, for instance, I notice that public class Tower extends GameObject. So I can make a Tower class, or if I make an object from this, Tower is going to be a type of GameObject. So we were talking about the advantages of this. One advantage is inside GameObject, if I write a single method distance, this takes the x and y value of any other object compared to the xy value of the object I happen to be looking at, and it will tell me the distance between those 2 objects. So this code is going to be written the same for each of the game objects. And so everyone, I just need to write this once, I put it in the abstract class, and I'm good to go. But I can also have, this is a method. It's not an abstract method, but if I put an abstract method in here, now this is an abstract method. This abstract method still says public, has a return type. It tells me it has a name and there's no input parameters, but I end it with a semicolon. There's no body here. This doesn't do anything inside this class. But now if I try to compile this, it says it's missing a method body. Oh, sorry. I'm going to say public. You need the keyword abstract. So now I have an abstract method. If I compile this guy compiles fine. But what I'm missing over here is if I come back to, for instance, game runner, and I try to compile this, it's going to go to these subclasses and it says, hey, this bullet is not abstract, and it doesn't override the abstract method update. So this knows that since I'm extending the GameObject class, and because the GameObject class has this method, so let's say right here I've got this abstract method, public abstract boolean update. I have to put this in the subclass, so the reason is why. So a regular method in an abstract class is available to all the subclasses, but this is going to force every subclass to have this method. Why is that important? Well, let's come back and take a look at the runner class, and I'm going to put in here a for loop, and this for loop is going to look at everything inside GameObject. So GameObject is an array list, or GameObjects is an array list of type GameObject, and what I'm loading into this are different types of GameObjects. So enemy is a type of GameObject because it extends GameObject. So is tower. Tower is a type of GameObject because it extends GameObject. And so now if I were to come through here and I were to look at each guy in GameObjects, so let's do that. I'm going to come in, I'm just going to say .getI, and this is going to now say update. Well, here's the problem. If I don't have this method in each of my my extended classes, then this will crash my program. This won't run. And so if I try to compile this now, for instance, it's going to say, hey, this guy doesn't have, you got this guy in this array list, and it doesn't have that method you want. And so you can think of this as kind of a contract. When you put this abstract method in here, it says any subclass has to have this. And the reason I'm not making it like the distance formula where I just write the code in here is because it allows you to differentiate in each of the subclasses. How do you update it might be different in each one. So it means that you have the possibility of changing it in each of the subclasses, but it doesn't allow the possibility that you'll forget to put this in and then end up with a program that's going to crash because you're calling this method back in that for loop, and if this method didn't exist in the subclass, it would crash. So let's see how to put this in, and that's kind of the big idea here. We're going to come back and we're going to say open this, let's say we'll open this up in the editor, and all I have to do now is I'm going to put in the abstract or the non-abstract method, and it's going to say public, and I'm going to return a boolean, and it's going to be called update, and not taking in any input parameters, and all I have to do in this case is return a boolean, so I'll return true. And so now this doesn't do anything, but at least this will compile and everything's okay. Now I'm going to take this same guy and I'll put it in each of my other subclasses. So for instance, if I come over here to this guy and say open an editor, I can go ahead and put him in here. And if I say compiles. Now that's good. Again, if I come over here and open him up in the editor, if I try to compile him, he's going to say no, I don't have this method that I need, and so now I can put this guy in, and he's good to go. So if I compile this, now I can compile the entire project, and so I have now everything set up so this guy compiles, and I have to go back in and I have to figure out how do I want to update the tower, how do I want to update the bullet, how do I want to update the enemy. Another example might be where I come in here and let's go ahead and create another abstract method called, let's say, move. Okay, so move now is something that if I want to move move this guy. Let's say I have an input value here of int, and let's say I have a speed variable. Okay, so essentially this is a simple abstract method. Again, it's just a signature public abstract void. I'm going to have a method called move, and I'm going to send in one variable which represents the speed. So back in any of my subclasses, I can see that this guy compiles, but if I come over here to the game runner and try to compile him, he's going to show me that I can't compile any of the subclasses now. So let's go ahead and put this in as another method. So I'll get rid of the word abstract, and I will define that method in here by simply coming like this, and I don't need to have I do need to have that, sorry. And I don't need to call this speed. I'll just call it, let's say, no, not X, let's call it S. And so the idea is that even though this isn't going to do anything in this particular place, now it will compile, and I can take that same method, and now it has a method, even though it's not doing anything at this point. But the key idea, again, is that it's going to allow me to put this, I can run through my array list, and I can go ahead and call this in every one of the subclasses because it exists in the subclasses. Let's see, that compiles now, and again, if I come back to this last guy and try to compile him, it says it won't compile because I don't have that method, so I'll put the method in here, and now I should have my entire project will compile. And so just real quickly, once again, the idea is that these subclasses inherit all of the methods that are in game class, all the public methods that are in game class, GameObject class. But if I come in here and look at this, it doesn't inherit these, but it forces the subclasses to have these methods, so move and speed. And so because these are not defined here, back in the subclasses, I can go ahead and write these differently. So the update for a tower is going to be different from an update for a turret, and so on and so forth. So that's the big idea with abstract classes. This idea of differentiating between all the subclasses, this update method can be different, is this idea of polymorphism, and the idea that if I want to find the distance between any two objects, they all use that same method that's back in the GameObject class called distance. That's the idea of inheritance. And so these are really key concepts for object-oriented programming, and this works really well when making a tower defense game.